Hello, back. Today we're going to be talking about patterns, which is Objective 2, and later on we'll be looking at Objective 3. Now, when we're going to be working with patterns, the first thing you want to do is to make a table of values. Now, the nth term is always the x variable, and we're going to use our calculator in order to help us solve these problems. So we're going to be tested with a problem that looks a little bit like this. A wall's being built with a sequence of concrete blocks as shown. Stage 1, there's 1 block. Stage 2, there's 3 blocks. Stage 3, there are 1, 2, 3, 4, 5 blocks. Stage 4, there are more. And which algebraic expression below can be used to determine the number of blocks y in the wall at each stage of construction x? Now what's key to this, and we mentioned this here a little bit ago, is that the nth term or the nth stage is the x variable. Notice that they tell us that x is the stage in construction. So we start making ourselves a table of values. We're going to go x, y. Y is the number of blocks. At stage 1, notice there's just 1 block. At stage 2, that's this stage right here, there are 1, 2, 3 blocks. At stage 3, there are 1, 2, 3, 4, 5 blocks, and so on. Generally, within 3 stages, you should be able to find the correct pattern. Now, we can either work this as we did in the past by substituting A, B, C, and D, each one separately into the calculator, and then seeing which one matches our table. Or you can substitute in your x values and see which one gives you the correct y's. Now, what I'm going to choose to do is I'm going to choose to substitute them in to the calculator and see which one's going to match our table that we got. So, go to my y equals, I type in 2x, and I go second graph to get my table. So what we're going to do is we're going to look and see if our table matches the table we made earlier. Stage 1, 2 blocks is what the calculator says. You notice that doesn't match right away, so A is not the correct answer choice. So then we're going to go to y equals and clear that out. And let's try 4x minus 2. And again, we go second graph. So we'll see if 4x minus 2 gives us the correct table. So we notice 1, 2, again, doesn't match. Our first stage we had 1 block, not 2 blocks. So 4x minus 2 didn't work either. So we clear that out. Let's try 2x plus 1. And again, we try to match it. Go under our second table, and you see 1, 3. It should be 1, 1, so that one doesn't match either. So the answer choice has to be D, but let's be for sure. We're going to go 2x minus 1. Go to your table, and we'll see if finally that one happens to match. 1, 1, 2, 3, 3, 5. 1, 1, 2, 3, 3, 5. So we know that based on what we've just got through, finding out the answer choice D is the correct answer. Now, when we talked about functions, there was something that we did not mention, which was domain and range. Now, the domain is the set of allowable, or just all of your x values, domain being x. Note that when we're graphing stuff, an open circle means less than or greater than, and if the circle's closed in, you'll see an example of this in a second, it means less than or equal to or greater than or equal to. Range is a set of allowable y values, and one way that some people remember this is why don't the Rangers, and depending on how you feel about the Rangers, you can either say ever win or ever lose. I'm going to be kind and say, why don't the Rangers ever lose? The whole point of that was to link the word or the letter Y to the word range. So why don't the Rangers ever lose? Let's go ahead and take a look at the set of ordered pairs right here and find me the domain and range of the function. D is abbreviating for domain, R is abbreviating for range. Remember, domain are all of your x's, and range are all of your y's. Well, to find the domain, all you got to do is list your x's. 9, 0, 7, negative 3, and 9, which you really don't have to list twice, but I'll just go ahead. Range, 3, 4 is listed again, 7, -2. Now, on a test, you probably see those listed in numerical order. In other words, it'd be -3, 0, 7, 9, -2, 3, 4, 7. But you should be able to match the domain that you're given with the domain on a test. On a graph, here's an example of a type of question that will say, what is the domain of this function? Remember, domain are all of the x values. So what you're going to do is you're going to go to your function and try to find out how far to the left it goes and how far to the right it goes, because domain are your x values. In other words, what's the smallest x on the graph? What's the largest x on the graph? As we look at it, you should notice that the graph, the smallest x value is -3 right here. Notice that as we follow -3 up, it reaches this open circle right here. And as we go to the right, the largest x value is 3, little open circle right here. So our domain, remember our x values, so we can cross out a and b immediately, is from -3 to +3. Now, since those are open circles, you should remember that that means that it is the answer choice D, because the or equal to only comes when those circles right there, I know it's kind of hard to see, are actually filled in. So now we're going to take a look at some specific types of function, the first of which is a linear function. Now, a linear function makes a line when you graph it. So a line, notice a line has no curves in it. The x will always have an exponent of 1. That just means that you won't ever see x squared or x to the third. And it uses slope-intercept form, y equals mx plus b. And we've got a question that follows along with this. Which of the following is not a linear equation? Now, you could, if y is already by itself, put these in your graphing calculator and graph them. But it's a lot easier just to, at least for this one right here, notice that those x's are not any bigger than 1 as far as the exponent goes. We should also say with linear functions that x cannot be in the bottom of a fraction. So another little rule. So if you notice C right here, notice that x is in the bottom of a fraction. That means that C is not a linear function. Now if we type that in our calculator, anytime you got more than one thing in top or bottom of a fraction, we need to put parentheses around it. If we put answer choice C in your calculator, 4 divided by parentheses x minus 1. The reason we use parentheses is to trap the x and minus 1 both in the bottom underneath this division. When we graph that, you notice that clearly does not create just a single straight line. So again, C is the correct answer choice. So now we're into objective 3. We're going to find the x and y intercepts of a function, equation, or graph. The x-intercept is the point where the graph touches, guess what? The x-axis. The point will always be written some number, because your x will have some number associated with it, comma 0. To find the x-intercept, we plug 0 in, plug in 0 for y and solve for x. Now, the y-intercept is the point where the graph touches the y-axis. The point will be written 0, comma, some number. To find the y-intercept, we plug 0 in for x and solve for y. So when you're finding the intercept, you always do the opposite of what it's asking you to do. Based on what we just got through learning, see if you can find the x and y-axis intercepts, or rather just the y-intercept of this function. Now, before we get going too much further, remember that f of x can be treated as if it were just y. So anytime you see f of x, just call it y, and you should be in pretty good shape. Go ahead and find the y-intercept of this function, pausing the video, and press play when you're ready to see the answer. Okay, to find the y-intercept, you put 0 in for x. So y is equal to 3 times 0 minus 2. 0 minus 2 is negative 2 times 3, so y is equal to negative 6. So our y-intercept is negative 6. So looking at a graph, what are the x and y-axis intercepts of the function graphed below? Now what we're going to have is we're going to have a couple of answer choices. And see if you can go and find the x, y-axis intercepts of this graph. Pressing pause, and when you're ready to see the answer, please press play. You'll notice the graph crosses the y-axis at 5, so that's the point 0, 5. Crosses the x-axis at 4, so this is the point 4, 0. So we just need to figure out which answer choice matches these 2 points. We've got 4, 0, but 5, 0, so that's not it. 4, 0, 0, 5, that matches. 0, 4 and 0, 4, neither one of those will work, so the correct answer is G. Now that we've talked about the x and y-axis intercepts of a graph and usually a line, let's take a look at something called the slope. Now the slope indicates the steepness of a line. It's found by using rise over run. That's done on a graph. It's also known as rate of change. And you can find slope using the slope formula. y2 minus y1. By the way, the letter is m equal. They use m for the word slope. Over x2 minus x1. We're going to take a look at some types of slope. First of which, if the line goes up from left to right, so I'll draw my line in red here in a second. Let's draw some coordinates or some xy axes, and let's draw our lines in red. So if our line goes up from left to right, this is called a positive slope. If the line goes down from left to right, this is a negative slope. If the line goes straight up and down, it's undefined. And if the line goes straight left to right, it's horizontal. Your slope is said to be 0 slope. These two, undefined and 0 slope, are a little weird. Undefined slopes always have the equation x equals some number, and 0 slopes always have the equation y equals some number. They don't have any other variable than just x or y. Now here's 5 problems, all of which are going to require us to find the slope of the line. So there's 5 different problems, 1, and then 2, and then 3, and then 4, and then 5. So go ahead and pause the video, work these 5 problems out, and press play when you're ready to see the answer. So taking a look at the first one, we notice that it is a line, and to find the slope of a line, what we need to do is we need to use rise over run. That's if you have a graph. So we pick any point on the line, doesn't really matter. I try to usually pick points where it crosses through the corners. So here's a good point, and we're going to try to rise and run until we get to another point. So let's go ahead and follow the line along and find another point. There it is. So our rise over run, we go up 1, 2, 3. So our rise is a positive 3. Now our run is a positive 2 since we had to go 2 to the right. So our run is 2. So our rise over run is 3 over 2, which means our slope is 3/2. For the second problem, we've got to find the slope from an equation. In order to find the slope from an equation, you've got to get the equation into y equals mx plus b form. So we need to get the y by itself. I'm going to go ahead and box the y, let myself know that's what I'm trying to get by itself. And to get y by itself, I need to subtract 2x from both sides first, giving me negative 5y is equal to 10 minus 2x, which is the same thing as negative 2x plus 10. Still need to get the y by itself, so I divide all of my terms by negative 5, giving me y is equal to positive 2x over 5, plus 10 over negative 5, which is a negative 2. Note that when I divided by negative 5, I had to divide all of the terms, or all the things on both sides of the equal sign, by negative 5. So the slope is always represented by the letter m, which is next to the x. So our slope happens to be 2/5 in this example. So in the third example, we've got to get the slope, and to do that we've got 2 points. So what we're going to use is we're going to use the slope formula, y2 minus y1 over x2 minus x1, which means we need to label our points x1, y1, x2, y2. So we get 7 minus y1, which is negative 2, over x2, negative 9, minus x1, 4. 7 minus negative 2, that's 7 plus 2. Negative 9 minus 4 is negative 9 plus negative 4, negative 13, which gives us 9 over negative 13. So our slope for the third example is 9 over negative 13. Now we take a look at some of the other examples we were given. You'll remember, if it's y equals a number, that means that you have a 0 slope. If it's x equals a number, it's an undefined slope. So now that we've taken a look at linear functions, we're going to take a look at another type of function, which is quadratic. Now, to do that, we're going to talk about something called the parent function. The parent function is the simplest form of a function family. The two parent functions you need to know are linear and quadratic. Now the linear function is y equals x. That's the linear parent function. Quadratic parent function is y equals 2x squared. Linear function, when you graph it, you get a line. Quadratic parent function, when you graph it, you get something called a parabola or a U-shape. So based on what we just got through learning, which function is a parent function for the graph below? Let's take a look at our answer choices. This little U-shape matches which one of these ideas of a parent function? The correct answer should be choice C, because choice C is a U-shape, and you could find that real easily just by substituting each one of these into your y equals on your calculator and finding out which one gave you the same basic shape as what we were given on our graph. We're now going to take a look at something called parameter changes. Parameter changes have to do with changing the m or the b. When the slope or m is changed, the only thing that is affected is the slope or the steepness of the line. When the y-intercept or b is changed, the line moves up or down the y-axis. So suppose the line y equals 3/4 x minus 4 is drawn on a coordinate grid. So pretty much you're just going to graph that function in your calculator. A second line is drawn with a slope of 1. Which statement best describes the relationship between the two graphs? Well, there's really no point in trying to guess that. I mean, we could, but it'd be so much easier just to go to your y equals. Get your first equation, 3 divided by 4 times x, and then minus 4. And our second function, which, well, it just says the second line is drawn with the slope of 1. So we just need a line with the slope of 1. 1x plus or minus just some number. We can just do 1x. That line right there should have a slope of 1. Now what I want to do is I want to make my second graph a little darker, so I press enter on that little dash line at the far left of the calculator. And when I graph them, here's our first line, here's our second line. And we can answer the questions about our graphs using our calculator. So The second line is steeper than the first. Well, our second line's darker. Is that steeper? Does it go up faster than the first one? Well, sure, it sure does. So A is the correct answer choice. And the reason for that is the larger the slope, the steeper the line. Are the graphs perpendicular? Well, no, not at all. Is the second line less steep than the first? Well, we just got through discussing that the second line is steeper, and the graphs clearly are not parallel. So again, A is the correct answer choice. So now we're going to be given a graph, f of x equals x minus 6. Remember, we can always just call f of x y. And we've got y equal to x minus 6. And we're going to shift that graph or translate that graph up 6 units. What is the equation of the resulting graph? Well, if you move it up 6, remember that changes, moving up or down changes the y-intercept. So we're going to add 6 to that y-intercept, which is just going to give us y equal to x minus 6 plus 6, or y equal to x. That's one way to do it. So A is the correct answer choice. The other way you could do it is you could take the graph and shift it up 6. 1, 2, 3, 4, 5, 6. And then shift another point up 6. 1, 2, 3, 4, 5, 6. Connect your dots. And you could find, by punching these in the calculator one at a time, which one matches the new graph that you just got through drawing. You should find out that A does that for you.